Okay, so Said Ayuita was a African runner. He and another African runner named Kip Keogh invented something called altitude training, which was why they were so fast and so dominant for so long. They would run on the slopes of Mount Kilimanjaro, okay, at like a very high altitude, and their bodies would build up extra red blood cells to help them carry the oxygen, and then they would come down and compete at sea level and kick everybody's butt because of the increased oxygen carrying capacity of their blood, okay, something that was later used to cheat by actually just injecting people with red blood cells, okay, instead of actually making them earn it. It's called blood doping, okay, something that came about later as a result of these guys' discovery, okay. So he ran the 1,500 meters, which is 3 3/4 laps of the track in 3.5 minutes, okay. That means each lap was under a minute, okay. Some of the fastest high school runners, okay, that I ever coached would run it in 51 seconds, okay, and that's if they only ran one lap, okay. This guy was running 3 3/4 laps all at around that time, so he was really fast, okay. So what we're looking at here, okay, is we want to calculate what was his speed. The question gives us the distance, obviously 1,500 meters, okay, and the time. 3 minutes. How many seconds in a minute? 60. Okay, so in 3 minutes, there's 180 seconds. Agreed? All right, plus another 29. We're looking at 209.46 seconds for his time. Did I mention he ran barefoot? Yeah, he also ran barefoot. Okay? There's still a few Olympic runners, mostly the Ethiopians, who run barefoot. Okay? I think that's crazy, but hey, good for them if they can run that fast in their bare feet. Okay. All right, so we're looking for V. Okay, so V equals D over T. Good news about this question, you don't have to do any algebra. It's already set up to calculate this. So 1,500 meters divided by 209.46 seconds. Okay, meters divided by seconds gives me meters per second. So he ran at 7.16 meters per second. To give you an idea, that means that every second he covered the distance from here to the wall. And he ran that fast for 3.5 minutes. Okay, pretty impressive. All right, I'll give you some more time to get ahead of me again. Okay, so we have a young runner and an old runner who is still really fast for an old dude. He's as old as me and I'm nowhere near that fast anymore. Okay. So what we want to figure out here is how much of a head start does the young guy need to give the old guy so he doesn't hurt his feelings and they finish at the same time. Okay. If I want to know how big of a head start, I've got to calculate what? What's that? Time for each runner. I need to know how long it will take each runner to run 10 kilometers, and then I basically just subtract those two numbers and I've got the head start. Okay, so for the 18-year-old, okay, we know that the distance will be 10,000 meters. That's 10 kilometers. Okay, and we know that he can run at a speed of 4.38 meters per second. Okay, for the 50-year-old, we know that again the distance is 10,000 meters. Okay, and that the speed at which he can run is still a very impressive 4.27 meters per second. So it's the same calculation for both. I've got to manipulate V equals D over T so that I'm solving for T. So I'm going to multiply both sides by T. T comes over here, and then I'll divide both sides by V. All right, so my end calculation will be that T equals 10,000 meters, okay, divided by 4.38 meters per second. The meters will cancel. Sorry, I forgot to start my calculator there, guys. It's like 2,300 seconds or something, or 2,200 seconds, right? Yeah, 2,283. That number that I had from yesterday? Okay, 2,283. All right, so it takes the 18-year-old 2,283 seconds. Now remember, we want to keep all of our decimals in the calculator, okay, to make sure that we're being accurate. All right, for the old guy, we've got 10,000 meters divided by 4.27 meters per second. Meters are going to cancel. It's going to take him a little longer, 2,341 seconds. Okay, now I just need to subtract them to get the head start. All right, so if I subtract those two numbers there, so we'll take the bigger one, that one, minus that one there. Okay, we get 58.8 seconds, so 59 seconds basically. He's got to give him just under a minute, okay, of a head start. Everybody okay with that? Okay. What's the next one? Skydiving, right? All right, so this is very much like the elevator question that we did the other day, except this one is all which direction? Down. Now, here's the trick with this question. Does it ever explicitly say it's this many meters down? It doesn't, okay? This is an example of a question where we have to get the vector from the context of the question, okay? That is, we all know you can only fall down. Nobody falls up, okay? And so when you jump out of a plane, you don't go flying up above the plane, okay? So we have to get the context here from, or sorry, we have to get the vector from the context, because it does ask, what is her average velocity, magnitude, and direction, which is why we can say, in this case, down. We know that's the direction that you fall. That is gonna happen from time to time. Okay, I mean the vector part from the context, not the falling part, hopefully, okay? All right. So in part one, okay, the displacement is 625 meters down, and that takes 15.0 seconds. All right. And then in part two, okay, they fall 356 meters down, and that takes 142 seconds. A lot slower now that the parachute is open. Okay, so if I want to find the average velocity, I need total displacement and total time. All right, well, total displacement is, these are both down, so I can just add them together. All right, so 356 plus 625 should be 981 meters, okay, and then 157 seconds. Okay, if I divide those two numbers, then I should get that their average velocity is 6.25 meters per second down. Okay. Everybody all right with that one? Okay, that was 11, right? Okay, how many people are done 12? Okay, I'll give you a few more minutes on 12. If you're done 12, move on to number 1. That's down below there, okay? The stuff that's more about vectors. Okay, you can move on to number 1. I'll give you the list of ones I want you to do off of the second sheet in a minute. All right, so this last one's a little bit trickier because you do have to work a little bit backwards on it, okay? First thing still is to write down the givens, okay? There's 3 parts to this trip. Okay, so a car makes a 60-kilometer trip. That's the total distance. 60 kilometers, okay? At an average velocity of 40 kilometers per hour. Actually, it's average speed. Oh, sorry, in a direction due north. Okay, so this would be displacement, this would be velocity, okay? And it is 40 kilometers per hour. Okay, and it is north, and that is north. Okay, the trip consists of 3 parts. The car moves with a constant velocity of 25 kilometers per hour due north for the first 15 kilometers. Okay, so I've got V and D. Yeah, go ahead, guys. Good luck. Have a safe trip, too. It's ugly out there. Okay. And then for the second part, 62 kilometers per hour due north for 32 kilometers. Okay, and then with what velocity does the car travel the last 13-kilometer segment? Okay, so I know the displacement for every part and the total, which is nice. Okay, I know the average velocity for the entire trip. What can I find since I know the total displacement and the average velocity? If I had D and V, what can I find? Total time. Okay, so I'm going to find that. I'm going to find the time right now because it is something that I can find. Okay, so time total. Okay, and all I'm going to do is take V equals D over T and manipulate for T. Right, so T will equal D total over V average. Okay, so that'll be 60 over 40, and that should be 1.5 hours. Okay, because this is kilometers divided by kilometers per hour, so the kilometers will cancel, and I'll be left with hours. Okay, I know the whole trip takes an hour and a half. And I know the velocity and the displacement for part 1 and 2. Can I calculate how long each one of those would take? Okay, let's do that because it's something that we can do. Okay, if you're ever lost and you're not sure what to do next, just do whatever you can. And finding that stuff might actually help you determine what the next step is. Okay, so I'm going to find the time here. Okay, it's the same formula. I did the manipulation already. Okay, so T equals D over V. So that's going to be 15 kilometers, okay, divided by 25 kilometers per hour. Okay, so part 1 takes 0.6 hours. Okay, same thing for part 2. T equals D over V. So that'll be 32 divided by 62. Okay, so 0.516 hours. Okay, now the question wants to know what's the average velocity during this part of the trip? What do I need in order to get that? Okay, Scott. Time. Since I know the total time, and I know 2 out of the 3, can I find how long part 3 takes? Right? I just subtract the other 2 parts from the total and I have how long part 3 takes. Okay, so that's my next step. I'm going to find the time for part 3 because now I can. So I'm going to take that 1.5 and I'm going to subtract that, and then I'm going to subtract that. All right, so the last part takes 0.3838 hours. Okay, I have D and T now for part 3. 13 kilometers north divided by 0.3838 with all the decimals obviously from my calculator. Okay, so in the last one they're going to travel at about 34 kilometers an hour. Okay, everybody all right with that? I got 34.2 there because I was in a hurry to make the key and I rounded numbers off, which we know we're not supposed to do until the very end. Okay? It actually makes a big difference because I got 33 point something, okay, when I kept all the decimals because I'm dividing by a bigger number. Okay, Would I give you one like that on a quiz? No. Here's why. Did you have to do the same calculation 3 times? That's a waste of a question. To make you do the same thing 3 times is a waste of a question. I would never give you one like that. This was just so you had to practice doing that manipulation of V equals D over T. Okay? This is just a time-consuming step-by-step question. All right. Here's the ones I want you working on now. I would like you to do, so from this second one, the one that says Science 10 Vector Quantities Worksheet, I want you to do 1, 3, 5, and 9. 1, 3, 5, and 9, please. Okay, guys, we probably won't have time to go through those vector questions, but we're going to start graphing on Monday. That's still going to involve some V equals D over T and some algebra and things like that, okay? But we'll be looking at that. And those are the practice quizzes, guys, for next Friday's quiz. That is 3, 4, 5, and 6, okay? That has some V equals D over T stuff like we've been doing and some graphing stuff. Don't worry about trying the graphing stuff until we've actually covered it, okay? All right. Have a good weekend, you guys, but not too good.